Hello everyone, welcome back. Today we are going to talk about functions. So in this lesson, we're going to talk about functions. So a function is like a mini program within your main program. So it is a reusable block of code that performs a specific task. Instead of writing the same code repeatedly, we can put that code in a function and just call it whenever we need it. So we write it once, we write the function once, and we can use it multiple times. So it saves the time and effort. So if you have a program that calculates, for example, the sum of two numbers in multiple places of your code, using a function avoids writing the same code again and again. So the program will become easier to understand and to maintain, of course. And functions break down, the complexity tasks, the complex tasks into smaller, manageable pieces. So, for example, here, if you remember previously, we were talking about like printing one thing here, like saying uh, the sum is, and then the number and L. So let me just initialize two numbers saying that int a equals 10 and int b equals 12, for example. And we are saying that the sum is a plus b, okay? So using these three lines, we can have the sum of a and b. However, just imagine that we have like 1000 lines and this code continues like for many times, and we have different blocks of codes here. Just imagine here we have a lot of codes and different tasks to be performed, and at some point again we would like to add two other numbers, like we would like to write down int c equals, for example, 15, and int d equals 20, for example. And then we see out the sum of c and d is c plus d and l. So you see, we are repeating this calculation again, and we had it one time here, and then we are repeating it here, and we may need to repeat it several times. So instead of writing these many codes repeatedly, we can simply just define a function to do the job for us. In order to define a function, we need to first declare it a priori to our main function. So this is our main function. So any C++ program will have a main function. Everything is within that main function. So before this main function, we can declare our additional functions that we would like to have. For example, here we declare a function called add, and it has two values as input values, int a and int b. So within the parentheses, it shows how many input it can take and what are the types of the input that it can take. So the first type is int a, so the first type is int and the second type is int. So the input of the function called add are two integers, and here this int shows the output of this function. So basically, we learned 3 points here. So this is the name of the function, and within the parentheses, we learn how many inputs the function has and what are the types of the inputs. In this case, they are both integers. It could be one integer, one float, it could be anything. And the third point that we learned here is that the output of this function, the resulting of this function would be also an integer. So we declare the function right here. So we are just saying the name, the output, and the inputs, and a semicolon, okay? Then when we come here in the main function, we call the function like this. So if we call the function, now the in the within this int main function we can call add. Why? Because initially a priori to this main function we have defined the function. Okay, so we must define it before the int main. So when we call it within the int main, so it recognizes it and it does not return an error. However, this function is just declared here. In order to know what this function do, I close the int main function. We go through the details of the function here. So basically, it would be something like this. We declare the function, we use the function. However, after the int main function is finished, we write down the details of the functionality of that function. So in order to do that, to see what this function is doing, we come to the end of the code. We exactly write what we wrote already for its declaration. Instead, we don't have a semicolon in the end, and we have two brackets within which we define the function. So every function has inputs and outputs. Here in our case, we have two inputs that are integers. And the output would be the value of a plus b. So this could be a plus b, or it could be like c plus d, whatever the input of the function is, it can add it. So basically we are saying if the input is a and b, so you return those gathered inputs. So this will return the value of this function. So we write down return and we do the addition here. So this is how this function would work, and we go up to the main function. So I summarize it one more time before I go into more details. We declare the function before the int main function. We define the function after the int main function and say what it is going to do. And it must have one return value. So it usually has either a return value or it's a void function. So void function, we will talk about it in a few seconds or in a few minutes. But in this case, because it's not a void, if it was void here instead of int, we had void. So it's not a void function. It's a normal function that returns an integer value. To return this integer value, we write down return and we do whatever we want to do here. So and then we want to use this function in the main function, in the main block of code. So we define one int result and its value is this. So this is how we call the function. If you remember, the function name was add. So it's going to call the function named add with two values, 5 and 3. And when it is going to call this function with 5 and 3, it's like saying that, okay, one input is 5, the other input is 3. So it's going to add 5 to 3 and it is returning its result, which is 8. So 8 is returned and assigned to the result. And now we are printing the value of result. Let me just compile it once. Okay, so now we see that the sum is 8. As we discussed, here we call the function with two inputs. So if we are saying the inputs are integer, they must be integer here as well. It's not like that we can declare them as integer and we can put like 5.2 and 3. It returns error. So they must be integer. So then 5 and 2 are called using add function, and 5 plus 2 plus 3, sorry, it will be 8, and 8 will be returned here as the number assigned to the result. So instead of, for example, adding the different integers and different parameters throughout the code again and again and again, so we don't need to write it anymore. We just, whenever we want to use it, we just call the function. So let me just do another thing. I would say int result 2 equals add, like we can say 10 and 2, for example. It's not possible to write 10 and 2.2. There will be a problem if we run the program. So, and then I see out the second sum is, and I print the value result 2 and del. So let me just compile this. Yeah. So here we see we didn't have to do the calculation anymore. We just call the function once more with new values. So you can call the function millions of times, and with new values you can do the calculation. However, the function is written only one time. So it is more efficient to have functions that do the job for you, so you don't have to call them one by one. So this is very important to keep in mind to use the functions. And another thing that we could do here is like the following. So as you see here, we are printing the sum is in the main block. In order to be super efficient, we can also mention that in this function we define a new integer called c that is equal to a plus b, and then we see out the sum is, and we print c every time. So here what we can do is like this. So let me just clear this part, and this and this. Let me see if I have errors or not. Okay, great. So you see, even now the code is even more clear. So here we are only saying add 5 and 3, add 10 and 2. So this is going to add any two numbers that are called using the add name, because the name of our function is like this. And this function now, it is actually not returning anything. So we can change the function to void. So what is void? Void, we change the function output, we put it void, and we forget about this. Let me just first run to see. Okay, great. So here, previously, we were doing the calculation directly. We were saying return a plus b. However, then we decided, and then the return value was being assigned to the result here. However, then we decided to not to assign these function values to any integer, and we do all the calculation in the function. So the code, the main block will be more clear. Therefore, we do the calculation here and we print everything here. So we are not printing anything here. So a void function is a function that is going to return no value. It's only doing some calculation. So now I change the integer output to a void value, to a void function, because it's not returning any value. It is simply just doing some calculation and printing something. If it is going to return something, it has to have some output data type like integer, float, double, etc. However, if it's not specifically returning something like this, like a plus b, for example, if it does not have something like this, it's a void function that is doing some calculation for us. So this was a brief introduction of the functions. In next lectures, we are going to do some coding exercises. Thanks for watching. Hello everyone, welcome back. Today we are going to do some coding exercises. So we would like to write a program that writes a function that greets everyone who is running the program. To do that, we could simply write down cout and write the message that we would like to have, like welcome here, and del. However, in the main function that we have in C++, we don't want to write anything like that, and we would like to only have codes that are calling the functions and tasks are done in the functions. Therefore, the code is more clean, more readable, and more understanding. So to do that, we define one void function here. So the name of the function is greet. It has no input. So let's see how it works. Before starting the int main, we learned that before that we need to declare the function, and we have the option of defining the function either after the int main or even before the int main. So in this case, I am declaring and defining a function, both of them, both tasks before the int main. So I will learn three things about functions. So this will be, the name is just something that is behind the parenthesis, just before the parenthesis. So the name is greet. Whatever that is in the parentheses is the input of the function, and whatever is just before the name is the output. So as the input, it has no input, so we don't need to put any input when we want to call it. So it's not like add function like addition, so we give two numbers, so it will do some mathematical operations with those inputs. It's just a simple greeting function, so it needs no input. Whenever we call it like this, it's going to be performed, and the output is void. Why? Because it is returning no value. So as you can see here, we are not writing return something here. Okay, as we are not writing that, this function is a void function. Whenever a function is returning a certain output, it is not a void function. But here we are doing nothing. So let's compile. Okay, now we see that the function is working very well. So instead of writing cout welcome to C++ and do some additions, do other things in the main part, we're just calling the function greet. So the code is very clean, and everything is done behind the scene. So this makes you to have a very good understanding of how the code work chronologically. So when you have, for example, 10 functions, from the beginning, you start, for example, greet, you go and read the function greet, and you come back here. Okay, the first step was greet. and then the second function is here, third, fourth, etc. So whenever you want to see the details of each function, you go and read that function. And in the main menu, in the main function, everything is clear and only the functions are there. And all the details, all the works, all of the coding details, and all of the works are within each function, making it uh, making the code to be more understanding and clear for the reader to see, okay, there are 10 functions here. If I want to read about the greet function, I click on the greet. So I can simply and easily navigate the greet function. Otherwise, I have to, look for every line to see where we are greeting when we are greeting the customers, for example, etc. So this is another example for greeting. In the next session, we're going to do some more coding exercises. Hello everyone, welcome back. In today's video, we are going to do another coding exercises. So we would like to write a function that does the multiplication of two double numbers. Previously, we learned how to multiply two numbers. However, using a function can help us to have a more efficient code. So we don't have to repeat a certain block of code repeatedly throughout our main function in order to perform a specific task for us. Using a function, we can define the function once and use it several times in the code, so it is more efficient. To do that, we learned before the int main function, if we want to have another function, there are two tasks that we need to take care of. So the first one is that we must declare the function before the int main function. So here we are declaring it. And also we need to define the function. But for definition of the function, we have the choice. Either we can define the function before the int main function, or we can do it afterwards. It's up to you. So in other exercises, I showed how we can only declare it above and define it in the after the int main function and use it in the main function. However, here I'm declaring and defining before the main function. And there are three things, if you remember, about a function that we understand from this line. So the first thing is its name, that is multiply. The second thing is within the parentheses, we learn how many input parameters it has and what are their data types. So here we learn there are two parameters as the input that this function requires to run, and the data types are double, and both of the inputs are double. Finally, the third thing about the function, we learn the output of the function. So the output of this function would be a double as well. So this is its declaration, and within the bracket, we will have the definition of the function. So this function is going to return x times y. So these two inputs are being multiplied using this function. And we have the return. Why? Because the output is doubled. So if anything but void is the type of the output of the function, there should be a return here. But if the function is a void function, there must not be a return here. So having said that, let's come back here in the int main function. So we would like to call the function in our main function. So I declare a double called result, and I assign the value of it by calling the function. I call the multiply function, and within the parentheses, we learned that this function requires two inputs that are doubled. So these two double number are also considered as the input of this function, and the output of this function is going to be assigned to result. Finally, we are going to print the result to see the output. Let's run the program once. So we see the product is 9. So this function, the analyze of code, would be something like this. Here we are calling the function with these two values. When we call them, the program goes up here and it says, okay, multiply 4.5 and 2. And let's return the value of 4.5 times 2. So it returns the value, and the returned value is assigned to result. So this is how a function would work. So one exercise for you could be how to change this double function, the output of this function is double, to a void function. I would suggest pause the video now and think about it. And if you have already thought about it, now you may continue. In order to do that, we we just replace double with void, and we forget about the return. We say int z equals, for example, y. And we simply just see out the value z here. Okay? Doing that, we don't even need this, and we don't even need this. So the code is even more efficient here. So it depends on what you want to do. But you see the code is very clear now. And let's see. Okay, so now everything works and the function uh, has changed to a void function. So more blocks are here. So we added one line and we changed the code in this line. However, our int main function is very clean. So if we want to do multiplication several times, like here, sorry, like here, and then here, we change the value, for example, 7, 9, 10, something like this. And we say the output of multiply function is. Okay. So instead of doing the calculation 4 times, I'm only calling the function 4 times. Let's see. Okay. So here we see that it is printing the output for us. So now every time that we call the multiply, it gets these two values in the parentheses, and then do the multiplication here and print it. So the first time when it's 4.5 and 2, it says, okay, 4.5 times 2, it will be assigned to z, which is 9, and then we print the 9. So this code is done. This line is executed. Then we have 7.5 and 5. It goes back up again. It says, okay, 7.5 times 5 will be assigned to z, which will be 37, and we're printing the 37. And it continues until the end. So you see how efficient it would be to write only a function that does the job for us instead of just repeating all of these blocks of codes again and again. So please don't forget to do the exercises yourself to get used to the syntaxes of how a function should be written and how a function would work. Hello everyone, welcome back. After discussing the definition and the declaration and the details of a function that we need to keep that in mind, the next topic that we're going to talk in today's session is about local and global variables. So a local variable is a variable defined inside a function or a block and is only accessible within that function or block. So once the function or block is done executing, the variable is destroyed and its value is no longer available. This is a definition of a local variable. And when we are talking about a global variable, we define it like it is defined like outside of all functions, usually at the top of the program, and can be assessed and modified by any function in the program. So it's important to differentiate these two concepts. In order to explain this, we brought you an example here. Let's recall how a function works and then we dive into this example. So we need to define a function, we need to declare a function before the main function that we know from before. In parentheses are the input of the function. In this case, it's empty, so there is no input. And before the name of the function, we have the output of the function. So the output of this function is void, so it's not going to return anything. These we already know from previous lessons. So then after declaration, we need to define the function. We have two options for this. Either it can be defined where it is declared like before the int main function, or it can be defined after the int main function. So we had the examples of both situations in previous lessons. So here I'm going to declare it before the int main function, and I'm going to define it also there before the int main function. So what it's going to do is that in the int main, so the program, when we run the program, only the int main function is going to be executed. And if I'm calling a function within the int main function, that function that is called is going to be executed. For example, if I simply remove this line, nothing is going to be executed because we didn't call the function so it can be executed. So it's an important thing to know. Because the function is declared and defined here, it doesn't mean that it's going to be executed. If you want it to be executed, you need to call it in the main function. Otherwise, it wouldn't just work. Let's try. We will see. You see, nothing is being executed because we are not calling anything. So it's important to call whatever function you're just trying to use, call it after declaration and definition. So we are just calling here the display function. And when we execute the code, it's going to come here. And then within that function, in that parenthesis, in that bracket, we have the definition of the function. So in the definition of the function, we are initializing one integer value called local num, and it is equal to 10. And then we are printing this value local num. Okay, so this local num is a local variable. Let me just change the name, maybe it would be confusing. I would say int x, for example. Okay, it's going to, so the number is, okay, so this x variable that is an integer is a local variable to this function. Okay, why? Because it is declared and initialized in this function, so it makes sense that it's not accessible from here. Why? Because it is not initialized and declared here. So what the program would see if we want to use something in the int main function, what it would see is the only thing that are here. And since it is not here, this integer value is not defined in here, it is a local variable for this function. We can have another, let me just add another function here. So I would say num2, and I define y and it is equal to 20. and it is okay. Now we have one main function, and then we have one void function and another void function. So we can have like tens of hundreds of functions. So it doesn't matter. So this integer that is called y, and it is initialized and set to 20, is a local variable to this function, and this y is not accessible neither in this function nor in the main function, so it's a local variable. So it makes sense. And also for this x is neither accessible in here nor here. So let me just run here. In the int main, we are calling the display number. So display number is this function. We are assigning 10 to integer x, and then we are printing it. So it is printing x. However, if we are trying to like print x directly here, it is expected to have some errors. You see, even we cannot even run it. We have error here. So why? Because it says use of undeclared identifier. It makes sense because x is defined here, so it's a local variable for this function and not for the main function. So this is the concept of local variable. In the next video, I'm going to talk about the global variables. Hello everyone, welcome back. In this session, we're going to talk about global variables. Previously, we talked about local variables, and we mentioned that local variables are defined within each function and only are accessible in that specific function. So if we have function number 1 and we define integer x, it is only accessible in function number 1 and not in function number 2 or int main function. So here we are going to discuss global variables. I have one int main variable here and one function here and a global variable here. So the global variable here, as you see, it is in none of the functions. So this is why it is variable. So this is the first function. This is the second function. So, and this variable is defined globally because it is not inside any specific function. Therefore, it can be used in any function. So, because it can be used in any function, in int main function, I'm going to print its value, its initial value. Okay. So let me just run this code. So as you know, whatever that is inside the int main function is going to be executed, nothing else. So if we are not going to call this function right now because we commented it, it's not going to call this function. This function is only going to be working if I call it in the int main function. So let's compile and see how the program would work only with this one line. Okay, so here we see that it says global number initially 100. So it says global number initially, this is the message we type, and then we print the value of global num. So the global num equals 100. It is printing it easily and it is accessible because it's a global number. So then we have the option of modifying that global number. So in order to do some modification and mathematical operations in this global number, we define a void function here. So a void function is defined before the int main. The input is empty and it is void, so it returns nothing. So basically in this function, when we call this function, we are going to add 50 value to its original value. So if you remember, when we have global num plus equal a number, it means that we are having like global num plus 50. Okay, so whatever the value of global num is, it is added with 50, and then its summation is going to be assigned to the global num. So in this case, it is 100 and it is 50, so the new value is 50. But for the sake of efficiency, we simply write it like that. So it's the same thing. So get used to also using equations like this. So we call this function here. This function is going to add 50 value to the original value of global num, and then it's going to print global num inside function, saying that global num, and then it is going to print this value. And here we have like global number after modification, and it is going to call this number again. So we are going to have three prints. Why? Firstly, in the int main function, I'm going to call global number initially, and this number is this number which is global, so it is accessible here. And then I'm going to call this function. This function is going to add 50 values to the original value of global num, which was originally 100. So therefore it is now 150. And it's going to also print the global number inside function message, and also print the new value of global number. So previously it was 100. Now we modified this number, and it is 150. So because it's a global number and it is now 150, we are printing it again, global number after modification. So we expect to see 150 here as well. So this is a global number done once in the int main, done once in this function, and also called again and used again in the int main. It is a very good example showing that how one global number is accessible from anywhere in the code. So let's compile and see how it works, and then we analyze the code. Okay, so let's analyze. So we have the global num here 100. When we call it initially in the main function, it says global num 100. So it is printing its value here. Then we are calling this function using this call. It is going to add 50 values to the global num, and it is going to print its new value as to be 150. Then when the work with this function is finished, the code is going to come back here and goes to the new line. So now it's going to print cout global number after modification, and it's going to print global num. And it's going to give us the 150. So we see that we can access the global number from anywhere. So let me just add something here. If we have another void function, modify to, for example, I would say, and then we are saying global num minus equal 100, and then we are going to cout the global num inside the second modified function is, then we have the global num handle. Okay, so and then I'm going to also call this new function tool. Sorry, the name is not correct. So whenever we are calling the function, even if it doesn't have any input, it's important to have the brackets, to have the parentheses. Sorry. So with this new defined function, we are going to subtract 100 values from the global number. So we had like 100 here, then we called this, and then it adds 50 values. So here it is 150. Then this function is done, where the program goes back to the main function and it is going to print 150. And then we are calling this second function. So the second function is going to reduce 100 value from the global num. So let's execute the code. Okay. So on top of what happened so far, we said that 100, 150, and 150 again. But here I modified the global number once more. So once more, I call a new function that is going to subtract 100 value from the last modified value for the global number. So it is going to simply do the modification like 150 minus 100, it will be 50, and it's going to show the result for us. So this is one thing. So this is what we need to know about the local and global variables. But another point to show the efficiency of functions is that here you see we are having two functions being called, and these are the things that I added simply because I wanted to have a better explanation of the code. These two lines can be also removed, but here and here we are just calling the functions and all the work is being done here. So if someone wants to read our code, it would be very easy for the reader to understand what we are doing here. So this is why we say we need to use functions to make the int main function as clear as possible. Thank you for watching. If you haven't had the chance to rate the course so far, please go ahead and do so. And also don't forget to give us your feedback. It would be valuable for us to improve the courses for future students. Thank you. Hello everyone, welcome back. Today we are going to talk about global and local variables. So now I'm giving you another example to distinguish these two variables, global and local, and also I'm going to talk about a scope resolution in this video. So before we dive into local and global variable, I'm going to give you another overview of what we have learned so far, and then I'm going to talk about global and local variable. I think we need to have a wrap up before we jump into more details of global and local variable. So far we learned that a function is like a mini program within our main program. So it is a usable block of code that performs a specific task. Instead of writing the same code repeatedly, we can put that code in a function and just call the function whenever we want. So this is what we learned about a function. And there are two things when we have the functions. There are two things that we need to consider. And those two things are the local variables and the global variables. However, before we jump into that, we have the declaration of the functions. So here, for example, we have the declaration of this function, and it has empty in the parentheses, meaning that it has no input, and the output, there is no output because it's a void function. So it is going to perform some tasks, some probably mathematical operations, etc., but it's not going to return anything for us. So given these introductions, we are going to now talk about how a global and a local variable are they're going to work for us and how they're going to help us to get what we want to do done. So let's walk through this code together. So here I have the int main function and I have certain block of code here, and I have one function declared and defined here, and we have the global variable defined here as global num, that is 20. So here it's a global variable, and since it is outside of any function, it can be used and modified by any function in the program. So this is why we are calling it global, and its initial value is 20. So it is initially defined to be 20. Then we have the void function that is going to do some tasks for us. So let's see what this function is going to do for us. So here we are declaring another integer variable with the same name as the name of our global variable. However, this is because it is redefined in this function, it is considered to be a local variable, although it has the same name. So it is a local variable and its value is set to be 10. Here, in order to distinguish these two, this function is going to print two values for us. Firstly, it's going to print the local value, the local variable that is a global num. So we are going to see the local value of this variable, and then we are going to see the global value of this global num. And to do that, we are distinguishing using these two lines, and then we are writing global num using scope resolution. So scope resolution means that if I only say global num, just like here, what the program will access is that, okay, you are using this local one. So you're calling this local one. However, so this is why we are just simply using printing global num, which means that this local variable will be printed. However, if because the local variable has the same name as the global variable, if we want to access and print this one, we need to use scope resolution. And scope resolution simply means that we have colon and then global num. Then it means that the program will realize that you are planning to use this number and not this number. To say it concisely, if you just write down global num, it's going to print this local variable. If you're using scope resolution, meaning that colon global num, the program will realize you would like to print the global num and not this local one. Okay, so let's now run the program and see how it works. So firstly, we are counting global num. So here we are simply printing this value, and we don't need a scope resolution. Why? Because we don't have any variable or any integer that is defined with the same name as the global num. Let me just run the code first, and then we are going to analyze the code once more. Okay, so here I'm saying that we have one function, one main function, and one function here, and one global variable. So initial value of the global variable is 20. Now in the int main, I'm going to print the value of our global variable here. So it is printing 20 because its initial value is 20 here. Okay. Then I'm calling the demo scope function. When I'm calling the demo scope function, the program is going to come here. It starts reading from here. Okay, the program will realize we are defining a new integer locally with the exact name of our global variable. It says, okay, it's a local variable, there is no problem. So it is equal to 10. Then we are printing the global num. So when we write down global num, it is going to print this value because it thinks that you're talking about the local global num. So it is going to print number 10. Then I would like to also print this global num, which is the global variable. To do that, I need to use a scope resolution. Scope resolution means that we have colon global num. This way, the program will realize I'm talking about this variable and not this one. Okay? To summarize, if we are having a function and within that function, we are declaring a new variable that has the same name as a global variable. When we are going to print that number, that variable, the local variable, we simply print it in that function. But if we want to access the global variable with the same name, we need to use the scope resolution. However, you may say, okay, why don't we use the scope resolution here in the int main function? The reason is that in the int main function, we didn't declare any variable with the same name of this global variable. Okay, so this is how the local and global variables are working, but I understand that in the beginning it may not be really easy to follow, but after a bit of exercise you're going to get the point. So it's very simple and very straightforward. Just think of it like this: we have a global variable here, it is accessible from anywhere. So if let me just write another function like void demo2, and I'm just here saying that hi from demo2, and we are printing the global variable, and then I'm saying global num. Okay, then I'm saying endl, and here I am just calling demo2. So let me just run this code. Okay, great. So this is what we wanted. Here, let's summarize. I'm having a main function. It is printing my variable here. Let me just rename it for the sake of easiness. I would say, for example, I would say like HE. Okay, this HE is going to change here and here and here and here and also here. Okay, let me just run the code to make sure that it works. Okay, it's the same thing now. Okay, so it would be easier to have this thing. So I have one main function. To summarize, I have one main function, two other functions, and one global variable. So this global variable is accessible everywhere in this code because it's global. So here I'm going to print the value of our global variable, which is HE. So HE is 20. Here we simply print it, okay? Uh, then I'm calling the demo scope function. When I'm calling the demo scope function, I'm initializing another variable which is local, and it is this variable, this HE is not accessible here or here because it's a local variable for this function only. Okay, but it happens to have the same name as our global variable. Because it has the same name, we need to distinguish them in that function for the compiler when we are using the variables. So in order to distinguish for the compiler, exceptionally in this function that has the same as a variable with the same name of the global variable, when we are just calling the name of that variable, it is going to print and execute whatever that is assigned to this local variable, because its local variable is prioritized. However, in this function, because we are having a local variable with the same name of a global variable, if we want to call and print this global variable, we must use scope resolution. So this way we are telling the compiler, okay, I know that I have a local variable with the same name, but I'm using a scope resolution for you to know that I mean, for this line, I mean the global variable and not this local variable. If you want to access the local variable, you simply just use HE. Okay? Then this program is executed. So it is printing the local variable, which is 10, using this line number 8. Yeah, line number 8 is going to execute this, and then it is going to execute this line number 9, which is going to print this line for us, which is the value of the global variable. Then it's finished. So we come back to the int main function and we have the demo2. So it is going to call demo2 now. The demo2 is couting, it's printing the global variable. So it says hi from demo2 and we are printing the global variable. So the value is 20. Okay, it is printing HE. Okay, so how straightforward is that? Is this. So to summarize, it is very straightforward. When we are having a local variable with the same name as the global variable, when you want to access the global variable, you must use scope resolution, means colon colon. However, if you don't have a local variable with the same name as the global variable, you can simply call the global variable by its name, like here and here. Okay. Thank you for watching. Don't forget to do the coding and do the exercises yourself so you can be more efficient and you can, get used to these syntaxes and these little details. Thank you. Hello everyone, welcome back. Today we're going to do some coding exercises regarding the local and global variables. We would like to write a program that declares a global variable to store a counter. So the program should have two functions. One increment counter, and this function should increment the counter by 1. And we have the main function, of course, which calls the increment counter function twice and displays the updated counter value each time. So now we know that we need to have a global variable. We need to declare a global variable. Then we need to have one function here and one function here. And so the main function is going to call the other function twice, and the other function needs to increment the counter or the global function by one value. So to do that, we start by declaring the global function. We know that from before, the global function, the global variable should be declared above the code and outside of any function. So this is the global function xy, we name it and we initialize it to be 0. Then here we have the main function and here is the increment counter function. In order to have a review, we know that a function has three associated data with it. So when we are declaring it, so now here it's the name of the function. Before the name is either void or the output of the function. So here, if it was instead of void, we had integer. we knew that the function should give us an integer value in the end, and so it returns one integer value. But because this function is returning nothing, we have the void function. And also within the parentheses, we will have the input variables of the function. So in this case, we have no input function, so we can just call the function without giving any input to it. So, and this is how we declare and define a function. And we know that we must declare the function a priori to the main function. However, for definition of a function in this part, we can do it either before the main function or after the main function. So it's up to you. Here, I'm declaring and defining at the same place before the main function. And here, what it's going to do is that it's going to get this xy and increment its current value by 1. So, and we learned that plus equal something means something like this. So instead of plus equal, we could write xy plus 1. So this equation here is exactly like this equation. So it says that whatever the value of x is, or xy is already, add 1 to it and assign it to xy again. So here xy is initially 0, and when we increment it by one value, we add one value to it, its final value will be 1. And then if we do it another time, its value will be 2, etc. And here we are having the main function. In the main function, we firstly learned whatever that is in the main function is going to be executed. So if we have a function here and it is declared and defined, but it is not called in the main function, it is not going to be executed. So here we are firstly printing the initial counter xy. So we expect to see value 0 in the output because initially the global variable number is 0. Then we call the increment counter as it was asked here 2 times. So we mention increment counter and increment counter. So in the first round, let me just type it like this. In the first round, it will be something like this. Xy equals xy plus 1. So for the first call, it will be like xy equals 0 plus 1 because its initial value will be 0 and we are incrementing it by one value. So the final value would be 1. For the second call, xy equals 1 plus 1, which will be 2. Why? Because initially it was 0. Then in the first call, we increase its value by 1, so it's 1 now. So when we are calling it one more time, its value is now 1 based on this equation, plus another 1 that we are adding here. So the final value will be 2. So we expect that now when this function is called for the first time, it is going to print the xy value, new xy value to be equal to 1. And when we call it for the second time, it's going to call this function again and add another one value to the already existing value of the xy, which will be 2. So let me compile. Okay, great. So here we see that the initial counter is 0. Here we're printing the initial counter to be 0 because xy is a global variable and it is initially set to be 0. Then we are calling the function one time. We are calling the function. So we are adding one value to already existing value of xy, which is 0. So it will be 1. And we say counter after increment xy. So it will print 1. And then this block of code is executed, and the program will go back here to execute the next line, which is increment counter for the second time. It comes back here, it is going to add another one value to the already existing value of xy, which is 1. So 1 plus 1 will be 2, so it is going to print 2. So this is how using global function will help us to access it through any function in the program. Thank you for watching, and don't forget to practice it by yourself. Hello everyone, and welcome back. In today's video, we are going to do another coding exercises with respect to the local and global variable in the function setting. So we would like to write a program that uses a local a local variable for us to store the values entered by the user. So the program should ask the user to input two numbers inside a function called add numbers. So far we know that we need to define a local variable, we need to have a function called add numbers, and that add numbers is going to read two input variables from the user, and then calculate the sum of the two variables, two numbers in the add number function, and display the result. Ensure the variables used in add number function are not accessible outside the function. So this is exactly highlighting the definition of the local variable. So to do that, we have two functions: a main function, which is going to call our function here, our other function, and a void function that is called add number. So previously we learned how to ask a user to enter a number, how to store the number that is entered by the user, and how to do the mathematical operations. However, we are using a function to do that for us, to make the code cleaner. So here the int main function is very clean. We're just calling the function and nothing more. So these dirty parts are done before the main function. So now here we are applying the same concept that we learned before, like doing the mathematical operations and reading and storing the data from the user in a function. So using a local variables. So here, in order to do that, we have add number function, which is void. So it's not going to return any value, and there is no input for it because everything is going to be stored here. Instead, we could add some lines in the int main function and ask the user to give us the input value, like two numbers, and those two numbers could be input value for the add number function. For example, let me make it more clear. So we could have int a equals 10, int b equals 14, and then have a function like add numbers or whatever that was going to have a and b as the input variables. But here we are seeing error because this function is defined in a way that it has no argument as the input. Therefore, adding a and b here will cause some errors here for us. So that would have been another option, to read and store the numbers in the int main function. But this could increase the complexity of coding in the input main function, in the int main function, and also make it a little bit, unclear. Instead of that, we are doing everything in add number. So here we are declaring two variables like x and y. And because they are defined in add numbers, they are inaccessible in any other function. So they are local variables. And we are asking the user enter the first number, we are storing it, then we are saying that, okay, enter the second number, and then we are storing it here. Then we are having another integer here that is called sum, and we are assigning the x plus y into that sum integer value, and then we are counting, we are printing the output, saying that the sum of x and y is the sum here, which will be the value of the x and y. So let's see how it works first. So it says that enter the first number, I would say 10. Enter the second number, I would say 25. So it says that the sum of 10 and 25 is 35. So here it is asking the first number, storing it, second number, storing it, do the calculation and printing the output. However, in order to show that this was a local variable, if I uncomment this line saying that directly please print the x value for us, it says use of undeclared identifier. Why? Because x was already defined here as a local variable, and in this function it is not accessible. If we are talking about one x here, we need to define that x here, okay? And if this x is defined here and we are printing something here, like let me just put 50 here and let's comment this part. So this printing syntax is going to print this x and not this x, okay? So because they are local. So this is how we need to as you see, when I commented this part, exactly the error came back because it says that use of undeclared identifier. There is no x declared in the int main function. If we are meaning this x, it is not accessible from this main function because it is a local variable for the add number function. So we learned about how to do the mathematical operations, how to do our calculation using different functions to keep the int main function more clean, and we learned about the concept of local and global variable. Thank you for watching. Hello everyone, welcome back. Today we are going to talk about function declaration with default parameters or default values. So these functions in C++, we have a function with default value is a function where one or more of its parameters are given default values during the function declaration. This means if we call the function and do not provide the argument for those parameters, the default values are used. And if they are called and with argument, those arguments are going to overwrite the default values. So let's illustrate this with an example. Here we have the main function, here is another function. Here we have the greet, it's the name of the function and it's a void function. And previously we had like int x in the parentheses, so the argument of the function was like an integer, but or input argument and input are the same, so I can use them interchangeably. So but here the argument of the function is a string which is called name here, okay? And the default value for this name is guest. So if we see this part like equals something in the parentheses in a function declaration, we realize that it's a function with default value. What does it mean? So first we go to the main function and we call the function. So when we are calling the function, you see here the argument is not given in this call. So when the argument is not given, this line, this part that is highlighted, would simply put the value guessed, would set the value guessed to the string name. So it would say, hello guest, welcome to the program. However, if we provide the argument and we call it here again, if we provide the argument, Alice would replace guest and it would say, hello Alice, welcome to the program. Let's run the code once. Okay, great. So here we are seeing that the first time we are calling the function with no argument, and it is just simply saying, hello guest, welcome to the program. And the second time we are giving the argument to call the function and it says, hello Alice, welcome to the program. So for the second time, Alice is replacing the word guest. So this function is very important to be used because otherwise we had to write two functions. Now we are only using one function. So if we call it with no argument, it's going to put the default guest to name, and guest is going to be printed here. But if we are calling it with certain argument, it's going to replace guest with the called argument and then print the output. Thank you for watching. Hello everyone, welcome back. Now we are going to do one coding exercises with respect to the functions with default parameters or default values. So we would like to write a program with a function that calculates the total price after a discount. So the function should take the original price as a required parameter and take the discount percentage as an optional parameter. So the default is 10%. So what I understand from this statement is that we need to write a function that calculates the discount. However, the discount amount by default is 10%, and there are some optional parameters that we can give, like 20, 30%, that they can calculate, the function can calculate it. So in this case, we need to have a function with a default value. Instead of having two functions, we can only write one function. So let's start from here. We start with the main function. So we print price after 10% of discount. Let's call the function calculate price. So let's go up in here to see the calculate price function. We see the name is calculate, the output is double, so it's going to return something, and it is indeed returning something. And in the parentheses, it is there are two arguments, there are two inputs. There are two arguments, one of which is price, the other one is discount. So both of them are double. However, price is a normal argument, but here the discount is a default parameter, because we are seeing that there is the equation sign here. So what it's going to do, here we are calling the function with the first argument only. So we are only sending the first argument, which is the price. We are saying that, okay, call the function for the price of 100. So 100 is set to the price here argument. Then we are going to declare a double that is called discounted price, and the discounted price equals price minus price times discount divided by 100. So it is going to give us the final price after the reduction of the discount. So it's a very straightforward formula. So what it's going to do is that, because we are calling the function only with the first argument, and since the second argument is a default parameter, so if we do not call the function with the second argument and only call it using the first argument, it's going to take 10% as the default value for the discount. So 10% is also assigned to this discount, and then the price minus, within parentheses we have price times discount divided by 100, and the final price is stored in the discounted price, and we return the discounted price here. Okay, and then we are saying that, again, see out price after 20% of discount. So let's call the same function, however with two arguments in this time. So in this time, the price is still 100. However, because the second argument of the function is a default function, we are calling the function using two arguments, and the second argument is going to overwrite this default value of 10. So now that we are calling it with 120, it's going to replace 10 with 20. So let's run the code and see how it works, and then we are going to analyze the code once more. Okay. So here we are seeing that price after 10% discount will be $90. So if you do the math, you will realize that 10% of 100% would be $10, and the reduction would be $10, and the final price would be $90. However, in the second case, because we are calling the function with the second argument as well, this 20% is going to be set to the discount instead of 10. Now, discounted price equals 100 minus 100 times 20 divided by 100. And therefore, the output would be 80. So the overall lesson, the key lesson of this lecture was to be aware if you are working with a default function. For example, in this case, there are two arguments for this function. The first one is a normal argument, and the second one is the optional argument, a default argument, or let's say optional. So if we call the function, we must at least have one argument, because the first one is not optional. The first one is mandatory. So you cannot write something like this. So see out the price and then calculate price. So it returns error. You see, because the first argument is a must, because it's not an optional. How do we know that it's not optional? Because it does not have an equal sign. So at least if we are calling this function, we must have one argument, okay? So if we have one argument like this, let me just comment these two lines. If we are having one argument like this, it is going to put 50 as the price and 10 as the discount by default. So let's run. Okay, we see that the price is 45. Let me just print the C out so it goes to the next line. It would be nicer. So see. Okay. So here we see that the calculated price is 50. The calculated price is called by the number 50, and then 50 is for the price, and then the discount by default is 10. So the output would be 45. And if we call it with no argument, for sure there is an error. You see, it's not working because it says that this function has one must argument. So if you're calling this function, you must have at least one argument. If you want, you can have the second argument, but this is not mandatory. For in this case, I'm going to put 20. So 20 is going to be set to the discount instead of 10. Why? Because the second argument is an optional argument. How do I know that it's an optional argument? There is an equal sign here. So let's compile again. Okay, you see, with the 10%, we had the output of 45. Now with 20%, we have the output of 40. So this is an efficient way to write only one function instead of two. So by default, it's going to take the value 10, and we can change it to 5, to 2, to whatever that we want. For example, here now it's 5. And then if we are investigating one specific case, the optional argument can be changed as we are going to call it in the int main function. So please don't forget to practice these practices, these coding exercises. In the next lecture, I'm going to do further coding exercises regarding this function with default values. Hello everyone, welcome back. Today we're going to practice some coding with respect to the functions with default values or default parameters or optional parameters. There are different names for them in the market, but whatever you are okay with, it's okay. So here now the program wants us to write a program with a function that prints a rectangle of stars. So the function should take the width and height as parameters and also default the width to 5 and the height to 3 if not specified. So specifically, this program is hinting us saying that, okay, you can take the width and height, and also the default width and height are 5 and 3. To do that, as always, we have one int function and we have another function here to do the calculation for us. Previously, we learned if we want to do print some like stars or matrix or something like that, we can use nested loops. So here we are going to use that knowledge to apply in this function. So this function's name is draw rectangle. It's a void function. It's not returning anything. It's just doing some calculation or maybe printing something. And there are two arguments for this function. The first one is int, and the second one is also int. And since it says that the width and the height, if they're not specified, there should be set to 5 and 3. So both of these two arguments are optional arguments. So if we call this function with no value, it's going to set the default value to 5 and 3. And if we specify, it's going to use the specified number to do the tasks. So what we're going to do here is that the default rectangle, here we are going to call the function with no argument. When we call the function with no argument, since these two arguments are optional, there is no problem. So it's going to set int row to 5 and int column to 3. So we are going to use a simple nested loop. So the first loop is starting from 0 to the number of row, in this case 5. And then in the inner loop is going to start from 0 and is going to until column, in this case is 3. And for each time, it's going to print the star for us. So let's run the code and see how it works. Okay, the default rectangle here. This is the first part that we ran. So let's first discuss this part. So here we are having 5 rows and we are having 3 columns because of the range of the I and the J. So it is printing the star. And in case you don't recall why 5 rows and 3 columns, I would recommend going back and checking out the videos for nested loops. There are some exercises there that I analyze the code one by one in the rows and columns to see why what is printed is printed. So it's going to, by default, set the row equals to 5 and set the columns equal to 3 when no argument is passed for this function. And both of the arguments are optional because they have the equal sign. However, when we want to have a customized function, we can say, for example, customize it. This is just a message to print. A customized rectangle with 7 and 4 would be something like this. We call the draw rectangle, and instead we are going to put 7 and 4. So let's see. So 7 rows and 4 columns. So simply it's going to take the 7 and put it as the row and 4 as the column. And then the range for I would be from 0 to 7 and from 0 to 3 for the J. But since this is the optional parameters, both of them are optional parameters, we can also call it with only one, for example, value here. So let's call it like this. Okay, so if we call it like this, it's going to print 7 rows, however, 3 columns. Why? Because this 7 is going to replace with is going to set to row, so I from 0 to 7. But because we don't have the second argument here, we are going to the function is going to use the default value 3. So this is why it is having the 3 columns and not 4, because the default value is taken there. So it's very important to practice all of these details to make sure that you're understanding everything and you're getting used to the syntaxes. Thank you for watching. Hello everyone, welcome back. Today we are going to talk about call by value. So there are two ways to call a function. One of them is call by value and the other one is call by reference. In today's lecture, we're going to talk about call by value. Later on in this course, we're going also to talk about call by reference. So what is a call by value? So in a call by value, a copy of the actual parameter, the value passed to the function, is made and used inside the function. So any modification to the parameter inside the function do not affect the original value in the calling function. So when a function is called, the values of the arguments are copied into the function's parameter. So changes made to the parameter inside the function are local to the function and do not affect the original argument. And why is call by value is so important? Why is it so important? So the original values remain unchanged, which is useful when we don't want a function to modify our data. So basically, what it means is that when we are calling a function using a call by value method, if we are passing like two numbers to the function, these two numbers are copied here. There are certain tasks done here and the function result is obvious. Then whatever the modification inside this function is done is going to stay inside this function. So if num1 equals 10 and there are some modification here, still the num1 is going to stay equals to 10 in the main function. So whatever the modification is there. It's not going to affect the int main function. So here we are going to write a program where a function calculates the sum of two numbers. So the values passed to the function should not change in the main function. So when it says should not change in the main function, in the main program, we realize it's asking us to do a call by value. To do that, we have one main program here and one function here. So here in the main function, I am initializing two numbers like int num1 equals 10 and num2 equals 20. Then I call the function. When I call the function, I pass these two arguments, and these two arguments are integer and they're not optional variables because they are not having the equal sign like the default parameters, like the optional parameters. So when we are calling this function, we must have both arguments, and we must have these two arguments being passed to this function. And the name of the function and the function is a void type. So in the function, it's very straightforward. We are going to say int sum is initialized and then the value a plus b is set to sum. Here we just mention whatever the integer we want to pass, but the name in the function is different. It's a and b. It could be anything. It's not important. So when num1 and num2 are passed here, num1 and num2 are going to replace int a and int b. Then it is going to do the addition, assign it to sum, and then see out the sum inside the function is, and print the value of sum. Then we are going to modify value a and b. So in this way, we are modifying the values passed to the function, but they are going to stay there locally. In these A equal to B and B equals to B does not affect num1 and num2 because it's a call by value. In order to make sure after this function is finished and the sum is printed here, and two modifications are done here, the sum is finished, then we go to the next line. So see out the value in the main function are still, we print num1 and we print num2 here and we return it. So let's run and see how it works. Okay, great. So we see that these two numbers are initialized and assigned values. Then we call the function, we go to the function, the addition is done, and the sum is printed. So it says the sum inside the function is 30. So the sum inside the function is 30. Here it means that 10 plus 20 is 30, so 30 is printed, and we are changing the value of A and B here. We are setting them to 0. However, when this function is finished, this line is finished, and then the program goes to this line. And when the program goes to this line, we will see that it says the value in the main are still 10 and 20. So these are the initial values set here. So these modifications are only for the local function and does not affect the main function. So this is the main purpose of calling by value. I would like to propose doing some exercises like this. So just solve and code this exercise yourself several times. In the next videos, we're going to solve some further exercises of call by value so we can see its importance. Hey everyone, welcome back. So we're going to do one coding exercises using call by value and show that using a call by value, when we call a function by value, it's not going to change the value of the original parameter, and it's going to change it only locally. So here we would like to write a program where a function attempts to swap two numbers using call by value. And we need to show the original values remained unchanged. So there are two things that we are going to learn. First, how to do the swap of two numbers using call by value, and also how to show that how to write these codes in the function and show that the original values remained unchanged. To do that, we have one main function and a swap function here. So we start from here. Every time you want to read your code, start from the main function, because whatever that is here is going to be executed. So here we are saying num1 equals 5, num2 equals 10. So we are initializing these two numbers, and we are saying that cout before function called num1 equals the value of num1 and num2 equals num2. So we expect that 5 and 10 is going to be printed here. Then we are calling the swap function and passing these two inputs or arguments. Then these two arguments are copied. Their original value is not going to go there. So a copy of them is going to go there because we are using a call by value. This is why the original number remains unchanged, in fact. So this function is called swap numbers. It's the name. There are two arguments. Both of them are integer, and the output, there is no output. It's a void function. To swap two numbers, one easy way and nice way is to define a new parameter. So here we are defining a new parameter. Just remember, like temp A and B. So we are firstly initializing a new parameter called temp, which is temporary. So we are putting a to temporary. So initially temp is empty, and the value of a is then set to temp. So the value of a is 5. So now temp equals 5. Then the value of b is assigned to a. So the value of b is 10, so it is assigned to a, so a is 10. And finally, the value of temp is assigned to b. So now temp is 5 and b will be 5. Okay, so one more time. So initially temp is empty. So the value of a is assigned to temp. So temp will be 5 because a is 5. Why a is 5? Because it's the first argument, and in the first argument we are passing num1 and num1 is 5. Okay, and num2 is 10. So the second argument is 10, therefore b is 10. So initially we are assigning a to temp, meaning that 5 equal, so temp equals 5. 5 is set to temp. Then we are putting whatever that is in b in a. So b is 10 and 10 is assigned to a. And in the last line, we are going to assign temp into b. So temp was 5 and 5 equals 10 then. 5 is assigned to b. Sorry. And then we are going to mention that inside the function, now a equals, we expect to have 10, a equals 10, and b equals, we are expecting to have it to be 5. So after doing all these modifications in this function, all of these are local. So we expect by swapping the values of the a and b, the values of num1 and num2 should not be affected because it's a call by value. So after this function is finished, then we are again here after function call, we are again printing num1 and num2 to make sure that everything is correct and these two remain unchanged. Let's run. Okay. So here, this line before function call, num1 equals 5, num2 equals 10. Okay. Then we are calling the function swap number. So here, as we went through the procedure twice, the procedure is done, so the numbers are swapped, and then we say, okay, inside the function, a is 1, a is 10, and b is 5. Therefore, the numbers are swapped. Okay. However, when this function is finished and the code is here, and then it wants to execute this line, it says after function call num1, you see num1 remains 5, and num2 remains 10. So the swap procedure in the local function, locally in this function, did not impact the main function. So this is the main purpose of the call by value. Firstly, we learned how to swap two numbers. We need to there may be many ways to do it, but the easiest way is to define a new integer called here like temp, and then using that we can swap the numbers. And then we learned that even though we swap the numbers in the function, it's not going to impact the original value in the int main function because it was done here locally. However, if we were doing all of these tasks in the int main function, of course, the swap would have worked and num1 in the end would have been 10 and num2 would have been 5. Thank you for watching. Hello everyone, welcome back. Today we are doing another coding exercises using call by value. So we're going to write a program where a function doubles the value of a number using call by value and show that the original value in main is unaffected. So even if it was not mentioning call by value, when it says that show the original value in the main function is unaffected, it means that we need to use the call by value. To do so, we have a function here to do the doubling the number and the main function. We always start from the main function. So we initialize one number as to be 15, then we print the value saying that before we call the function, the value is this. So we expect that it would print before function called number equals 15. Then we call the function with this number. So the number is passed to the this argument is passed to this function. So the name of the function, it's a void function, and it has only one argument, and it's a must argument. It's not optional because it does not have equal sign, etc. So it's a must argument. It's not optional, like the functions with default values. So I try to remind all of these things while I'm talking to let you hear them again and again, so somehow you learn it by heart. So here, what this function is going to do is that it's going to take the n and double the number and print the number. So it's going to take the number 15, and then this number is doubled and the value is printed. So 15 times 2, it will be 30. 30 is going to be printed as the new value of n because we assigned 15 times 2 is assigned to n again. So the new value of n is 30. However, when this function is finished, the code finishes this line of execution and it goes to the next line. After function called number equals 2, we expect to show the number 15 here again. Why? Because we are using call by value. Let's run the code and see how it goes. Okay, so let's analyze the code one more time. Here we are initializing the number, it's equal to 15. We say before function call number equals 15 because it is initialized here and we're just printing it here, so it is 15. We call the function, we go to the function, we double the number and we print the value. So when we double the number using this line, it's going to print 30 for us. So here n equals 30. We modified the value of n. And when this function is finished, we are in this line, and the program goes to execute line number 14. So after function call number equals, we're going to print this, it still prints 15. So whatever the modification is done, it's done in this function locally, and it does not impact the original value of the number. Why? Because we are calling by value. So when we are calling by value, this original number is not passed to this function, but a copy of this number is passed to do further mathematical operations here. And that's it. So the original number remains the same. This is how call by value will work. However, in call by reference, things are different. So in the next video, we're going to talk about how to call a function by reference. Thanks for watching. And if you haven't had the chance yet to rate the course, we appreciate it if you could give it the stars, and also if you have some constructive feedback and comments, we appreciate to have them because it would help us to improve the course for future students. Thank you very much. Hello everyone, welcome back. Today we're going to talk about call by references. So far we learned how to call a function by value, and we learned about the details. We did some coding exercises with respect to that. Today we're going to move on and focus on call by reference. So there are two main way to call a function. So the first one was call by value. Now we're going to focus on call by reference. So what a call by reference is. So in a call by reference, instead of passing a copy of the value, a function receives the reference or the memory address, let's say, of the variable. So this means that any changes made to the parameter inside the function directly affect the original value. Why? Because it's not receiving a copy of it, but its reference, which is the memory address. So it is going to directly manipulate and modify the original value. So when a function called, instead of creating a copy of the argument, the function works directly with the original value in call by reference. So let's learn it with an example. So here we're going to write a program that swaps two numbers using call by reference. So it wants us to define a function that swaps the value of two variables and call the function from the main function and show the values are swapped. Previously, we solved this program already with the call by value. There, only the numbers that were swapped in the function, they were locally changed, but in the main function, they didn't change. However, they are going to be changed here because we're calling them by reference. So basically, to do so, we know that we need to have two numbers and a function to do the swap for us. So here is our int main function, and here is another function that we have, the swap function. It's a void function, and the arguments of this function are two parameters. There are two arguments, let's say, and both of them are having integer data type. And so previously we were just writing down int a or int b. Now we are having this reference sign here, the and sign. So this and sign is for the call by reference. So this and sign means that go and check the address of where this argument is stored. Again, here this and sign means that go and check where the address of this B is and where it is stored. Let's dive in. So we initialize and declare two integers here, num1 and num2. The first one is 5 and the second one is 10. And we print the value of these two numbers, saying that before swapping, num1 equals 5 and num2 equals 10. Then we are going to call this swap numbers function, which is this one, and we are passing these two arguments, these two input values. So by passing these two arguments, the program, while being executed, will go and starts from here, which is the function, okay? So when it goes here, because the function is defined in a way to go and check the reference, it's going to check where the variable is initially and originally stored in the memory. Therefore, it is going to directly work with that. So this is why we call it call by reference, because it's going to check the reference and original place where the variable is storing. However, just note that when we are calling by reference, here nothing changes. It is exactly similar to the call by value. The change is only these two ands, okay? Then to do the swap, we define a new integer. We put the value of a into temp. So let me go through the analyzing of code like before. It would be easier for you to understand. So here we are having this, something like this. So temp is empty in the beginning. So the value of a is assigned to temp. So a is 5 because a is the first argument, and here the first argument is num1 and the num1 equals 5. So a is assigned to temp, so 5 is assigned to temp. Then b is assigned to a, so a equals 10. Why 10? Because b is the second argument, and here the second argument is num2, and num2 equals 10. So 10 is assigned to a. And finally, temp is assigned to b. So temp was 5, and now 10 was assigned to b. So we did the swap using these three lines. Initially, a was 5, b was 10, but now after swapping, a is 10, b is 5. So done. We swapped the numbers. So when the function is finished here, this line of code is executed. So the program goes to this line where it is printing after swapping. So num1 equals, we print the value of num1 again, and we print the value of num2 again. So let's run and see how it works, and we're going to analyze the code once more. Okay, so here we see that the code is initializing these two variables, then it is printing before swapping num1 equals 5, num2 equals 10. So num1 equals 5, which is true, and num2 equals 10, which is again true because they were initialized just like 2 lines above. Then it is going to call this function. This function is going to swap these two values. However, because it's a call by reference using these two and signs, we know that if there is a change, it is going to impact these two numbers because it's a call by reference. So the swap procedure is done here. So this line is executed. Then the program is going to line 19. So, and it is printing after swapping num1 equals 10 and num2 equals 5. So we see that using call by reference, whatever we do, even locally in this function, since it's a call by reference, it's going to impact the original value of the numbers even in the int main function. So something to keep that in mind. So if I remove these two and, it will become like a call by value. So the the values are not going to change. So let's try them here. So you can see. Okay, as you see here, I removed the and sign here and the and sign here. So this is not a call by reference anymore. This is a call by value. So in this case, when a call by value is done, the program is executed like this. So it is printing 5 and 10 using this line, which is the original value. Then it is going to call this function. This function is doing the swap, and then when the function is finished, it is going to print again the values of num1 and num2. However, the values of num1 and num2 are exactly the same initial values because it's not a call by reference and it's a call by value. So in a call by value, we learned that we are not going to modify the original value but a copy of the value. So this is why we call it call by value. However, in a call by reference, we are giving the address where these two variables are stored. Therefore, the function is going to directly go there, find them, find the reference, and directly work with the original values. So I made it like to be call by reference again by adding these two ands. And we see here the first number is 5 and 10. It is printed. Then the function is called. And then when we are printing again the num1 and num2, the values have swapped. So this is important to know the differences between the call by value and call by reference, but because in different there are two different and separated things, and in programming, as per our need, we need to choose from either of them depending on what the goal of our program is. So keep that in mind, keep practicing, and try to play with call by reference and call by value by solving the exercises that I provided in different videos so you can master it. Thanks for watching. Hello everyone, welcome back. Today we are going to do another coding exercises using call by reference. So we would like to write a program where a function doubles the value of a number using call by reference. So we need to define a function. We are asked to define a function that modifies the value of the past variables. So call the function from the main function and show that the original variable is updated. So even if the program was not mentioning using call by reference, when they are saying that show that the original variable is updated, we need to get it. Okay, it's talking about call by reference and not call by value. So in order to do that, we define a function that is going to modify the value of the past variable, and we need to write a function that doubles the value of a number. So here we have the main function, and here we have the function that does the work for us. So here it's a void function, and it is having only one argument, and it's an integer, and because it's a call by reference, we know that we need to put the and before the name of the integer. So the compiler would understand we're talking about call by reference. Okay, to do that, in the int main, we initialize the number to 15, then we print the value. We print the value, okay, we say before doubling number equals, and we print the value of it, which is expected to be 15 because we just initialize it. Then we are calling the double value function using one argument, and the argument is this number 15. And just note that in call by reference and in call by value, there is no difference for calling the function in this part. The only difference is this and added to the argument in the function declaration. Then this function gets the number address, so it is going to directly work with the original value and not a copy of it like call by value. And here it says, okay, whatever n is, make it multiplied by 2 and store it in n. So this way, the multiplied number, the multiplied of the number is stored in n, and the function is done. So when the function is done, the program is going to execute the next line, and we are saying after doubling number equals, we expect to see 30. So let's check. Okay, great. So here it is 15. It's going to print 15, and it's going to do the doubling using this double value, and it is simply just performing this equation times 2. So whatever the number is past this n is here times 2, and then put it to the value of n. So modify it, update it. So if it's 15, it's going to be 15 times 2. If it's 10, 10 times 2, whatever the n is, that is passed here using the number that is initialized here. So it is going to be multiplied by 2. If I put 10 here instead of 15 and then pass the number, it is going to be 10 times 2. So then when it's done, it is going now to print the after doubling. So the value is updated because it's a call by reference. And if I want to make it like a call by value, I simply remove this and sign, I save, and I compile again. Okay, you see? So here, when it's a call by value, now it's not a call by reference anymore. It's a call by value, and you see that whatever modification in this function was, it doesn't matter, and the before and the after, like before doubling and after doubling, the value of the number remains the same. Why? It's a call by value now. It does not have the and sign, so it is going to work with a copy of the original number. When we put the sign, it is going to work with the original number directly, and it's going to update the original number and modifies it. So keep that in mind. It's very straightforward, but we need to do the practice to master it. Hello everyone, welcome back. Let's do another coding exercise using call by reference. So we would like to write a program where a function updates two numbers by reference. Add 10 to the first number, multiply the second number by 2, and then call the function and show both numbers are updated. When it says both numbers are updated, we know that we need to use call by reference, even if it was not being mentioned here. Okay, to do that, we have one int function and one function that does the work for us. The update value function, update value is the name of the function. It's a void function. It is having two arguments. The first one is integer. The second one is also integer. The first one is x. The second one is named y. Because it's a call by reference, we have this and sign before the name of our integers. So we initialize two numbers, 20 and 15. They mentioned that add 10 to the first one and multiply the second one by 2. We say, okay. So let's first print the numbers before doing any modification. So before doing any modification, we say before update num1 equals, we print number num1. like here, and we show this message, and then we print num2, which is 15. So we expect to see 20 and 15 in by executing this line of the code. Then we are calling by reference this function. So here the first argument is x and the second argument is y. So the first argument and the second argument. And for the first one, we need to add it by 10. For the second one, we need to multiply it by 2. So x, we are adding whatever the value of x is, we are adding 10 values to it using plus equal. And then whatever the value of y is, we are multiplying it by 2 by star equal. We know from before, instead of writing, for example, instead of writing x equals x plus 10, we can write x plus equal 10. Okay, and we also know for efficiency, instead of writing y equals y star 2, we can simply say y star equal to. They does the same job, they do the same job, however it's more concise, so we are using this way. So it is simply just adding 10 values to whatever the value of x is, and it is multiplying y by 2, whatever the value of y is. So this function is very simple and it's done. When the execution of this line, this function is finished, it is going to next line where we are printing after update num1 equals, and then we are printing num1, and then we are printing num2. Here we are expecting to see different numbers. So the first number was 20. We added 10 values to it. So here we are expecting to see 30 now. And the initial num2 was 15, and we multiplied this by 2, and we are expecting to see 30 here. Let's compile. Okay, great. So we are seeing what we want to see. So 20 and 15 is passed to this function. Before passing, it says num1 equals 20, just like here, num2 equals 15, just like here. Then this function is called, we are going to this function. This function is adding 10 to the first num, so num1, instead of 20, it is now 30, which is shown here. And then the second argument, num2, which is y here, so it is multiplied by 2, and it is now 30. And this is what we wanted to do, and it did the job. So call by reference, modifying the original value. So please start doing the coding of these exercises that I do, and make errors, because when you make errors, you're going to learn from those errors and see how the syntaxes are working all together. It is very important to do that. Thank you for watching. Hello everyone, and welcome back. Today we are going to do one coding exercises using template functions. So we would like to write a program that swaps two values, the first value and two value of a function. So whatever we pass as an argument to a function, we would like this function to swap their place. So when we are, for example, passing two values like x and y, we would like to see in the output y and x. Okay, we would like to swap their values. To do that, we have a function, and it happens to be a template function, because we discussed that instead of having multiple functions doing the same thing for different outputs, like for integer, float, etc., we can have one unique function that does everything, and it has to be a type of template. So to do that, we know that we need to include this header. So the function that does the swap is the swap value. It's a void function. It's not returning anything. And as an argument, as the argument, it is taking two arguments. So their type is t. So it's a t. And then here we will see that it has the a and b argument. And they are called by reference because we have the and sign behind the name of the the arguments. So when we have the and sign there, it means that it's a call by reference. And just please note that it's a void function and not a t function. So if it was supposed to have some output, we could write t here. Okay, so if it was going to return something in the end, so it could be t, so the output would be like t, a template, so the compiler would decide about that. However, we don't have any output. You see, we don't have any return. We are just doing some tasks here, and we are doing it by call by reference because we would like to actually modify the original values. Okay, let's try and see how this function works with different arguments. Initially, we define two integers. They are named x and y. Their values are 10 and 20. Then we have two float. Their names are p and q. One of them is 1.5 and the other one is 2.5. And lastly, we have two strings, str1 and str2. One of them is hello and the other one is word. So we would like to use these set of arguments to call this function to swap their values. So when we are going to call this function, in the end, the value of x should be equal to 20 and the value of y should be equal to 10. The same here and the same here. Let's see. So we are first printing before swapping x equals, so it will be 10 because we haven't done anything, and y equals, it will be 20 because we haven't done anything yet. Okay. Then we are calling the swap function with x and y. So with x and y, we are calling by reference the function. Why the reference? Because we see that we have the and sign, and when we are calling by reference using the and sign, it means that we are going to modify the original value. So the x and y will be modified here in the int main function. And we know how to swap the values. We define a new data type. The data type is template here because one time it's going to take int, one time it's going to be float, one time it's going to be a string. So it can be t. So therefore the compiler will decide what to choose as the type of this data. So we declare and initialize t. So whatever that is in a, we put it in t, in temp. Then whatever that is in b, we put it in a, and whatever that is in temp, we put it in b. This way, we're going to swap the values. Then when this function has finished, so here we called the function with x and y. So we did the swap and this function is finished. So the program is going to execute this line. It is saying that after swapping x equals and y equals. So we expect that now that we are printing after swapping line, x will equal 20 and y will equal 10. The same here. So here we are saying that before swapping p equals, it's 1.5 and e equals 2.5. Then again, we are calling the function with these two arguments, p and q. Then it is going to treat the arguments the same as before. It's a call by reference still, so because we didn't change anything. And now t will be float. Previously it was integer, but now that we have the float arguments, it's going to be float. Then it is going to do the swapping, and after swapping we are printing the value of p and q. So p should be 2.5 in the end because it is changed, and q should be 1.5. Finally, we are printing before swapping the value of str1 and str2, which will be hello and word here. Then we call the function one more time with these two arguments that are strings, so it's going to be there, and then the t value will be chosen by the t data type will be chosen by the compiler, but in this case it's going to choose string because we have two string arguments. So it is going to swap their values, and after swapping, str1 should be equal to word and str2 should be equal to hello. Let's compile and see. Okay, great. So here we see, let's start from here. Okay, so we see before swapping x equals 10, y equals 20, exactly like this. Then after swapping x equals 20, y equals 10. So there are two lessons here. First, call by reference, it's going to modify the original value in not even if it's in another function. Second, we use the template data type. So the function, the compiler decided about the data type of the arguments and of the temp. And in our case, it was integer, so it's integer. Then we are having here, okay, before it's p equals 1.5 and q equals 2.5. This is exactly the same. So the assigned numbers unprinted. Then we call the swap value function. It does the swapping. And then we see that the value of p is 2.5 and q is 1.5. So it is changed. And finally, let me just get it above here so it would be also easy. Oops, sorry. So to also trace the program from here. Okay, so here we are printing the str1 and str2. So str1 is hello, str2 is word. So it is before swapping, it says str1 is hello and str2 is word. Then we call the function, we do the swapping here, and then after swapping, when we print str1 equals word and str2 equals hello. We see that using template function, we can do the swapping tasks. Not important, and it's not important the data type of the arguments. So whatever that is here, it is going to be adapted to that. So that's very nice. And then because we use the call by reference using this and these two and signs, it's going to modify the original value. Thank you very much for watching, and please do the exercises yourself, try them to see where you make mistakes. Those are the places you can learn from and improve your coding from there. Thank you very much for watching. If you haven't had the chance to rate this course, we would very much appreciate it to go and rate it. And also, please provide us with your constructive comments. It would help us to improve our teaching and our methods and our courses for future students. Thank you very much. Hello everyone, welcome back. So far we learned about call by value and call by reference. To make a summary, a call by value copy is a copy of the value, so it's not going to modify the original data and does not impact the original data. So when we don't want to modify the original data, we are going to use call by value. And when we would like to modify the original data, we are going to use call by reference. So a reference to the actual variable is used, therefore the original value is changed. However, today we're going to talk about template function. So a template function in C++ is a way to write a single function that works with different data types without rewriting the same function for each type. So instead of specifying the data type like int, float, or string, we can use a placeholder that the compiler replaces with the actual type during the compilation. So just write one function that works for multiple data types instead of creating separate functions for int, float, and other types. Let me explain it using an example. So previously, when we were talking about a function, we had the name of the function, we had the type of the output here, like if it was void, there was no output, otherwise int, a float, double, etc. So from this data type before the name of the function, we could understand the output of the function, the data type of the output of the function. And also in the parentheses, when we were having the arguments, we were having like int a, int b. So we were knowing that the input must be integer and not a double. So when we were talking about having int a, we knew that when we are going to call this function, we must pass the argument that is integer. And if it was defined to be an integer and we were passing like a double number, it was returning error. So in order to avoid writing different functions that works and do the same for us, do the same thing for us, but having different input and output, like we could write one function for the float, another function for double, another function for integers, another function for a string, etc. Instead of doing that, we can write a more generalized function and let the compiler decide about the type of the input and the output. To do that, we need to include this in the top on the top of our code, like template. Within the angle bracket we have the type name t. So this is something that we need to include, like using namespace std, etc. After including this, we can simply define the output of the function to be t and the input of and the types of the arguments or inputs to be also t, like here. Okay, when we did that, we can easily just use this function for integers, for doubles, for whatever we want. So let's see what we would like to write. We would like to write a template function that takes two inputs and returns the larger of the two. So the function should work for any data type, int, float, double, etc. So even if it was not directly mentioning to write a template function, by saying that the function should work for any data type, we could guess that it is asking for a template function, because only a template function can do that for us. So let's dive into the code. So int main is having 3 lines only. So the first line says that max of 3 and 7, and then call the find max function with two numbers 3 and 7. Okay, when it is calling the function, it is going to start running the function. So using ternary operator, there is a condition here saying that in the condition, if you remember the ternary conditions, ternary operators, we were having like the first and the second. It is saying that A is greater than B. Okay, so this is the condition. The condition is separated from the possible outcome with a question mark. So these are two possible outcomes, and two possible outcomes are being separated with a colon. Okay, so it is saying if A is greater than B, return A. Okay, but if this condition is true, just return the first number, just return the first possible output. However, if this condition is not true, just return the second defined number. Okay, second defined integer or variable here, second defined possible outcome here. Okay, so we are passing 3 and 7, and so 3 and 7 is here. So because 3 and 7 are integer, the compiler will realize that the arguments are integers. It is done automatically by the compiler. So it says 3, is it larger than 7? No, therefore, because it is not passing this condition, so it is not going to return A, but it is going to return B. So B is returned. Okay. Then it goes to the next line, says that max of 4.5 and 2.3, and then calling the function, putting 4.5 and 2.3. So instead of you know, just defining another function, we can simply just use double or float number here, as you can see. So it is calling the function again. So the function automatically realized that, okay, we're talking about float numbers, so the arguments are floats, so the output should be float. And it is saying that, okay, it is checking the condition A and B. So A would be the first argument because it is A, and the second argument would be b, which is 2.3. It is mentioning, it is checking the condition that if 4.5 is bigger than 2.3, if this condition is true, which is true, the first condition, the first possible outcome, which is a, is returned. Okay, so 4.5 is returned. Then the program is executed and it goes to the last line. It is saying max of a and z. So basically, we can compare characters. Each of these characters are having an associate number. So it is going to say that, okay, find max with A and Z. It works for characters, okay? So we don't need to define a separate function. So the compiler will automatically realize, okay, we're comparing characters. It is going to check if A is greater than B. If this is true, A is going to be returned. If this condition is not true, B is going to be returned. So after analyzing the code, let's compile and see the results, and then we are going to do the checking one more time. Okay, so it is starting from here. It is saying that max of 3 and 7 is 7. It is integer value, both of them are integers. Integers are passed as arguments, and it is found that 7 is bigger, which is true. Then two float numbers are passed, like 4.5 and 2.3, and it is okay again because it's a t template function and we're putting t here, so the compiler automatically realizes that we are talking about float. And then it is finding the maximum between a and z, and then it is comparing, and z has the larger, let's say, behind the scene value, because each of the characters are associated with a number. So it starts with a, and as we move forward to b, c, etc., their associated value is going to increase. Therefore z, having that, it is comparing those numbers with each other. So therefore z is larger, and it is going to show z in the output. So this is template function. It's very easy and it works very well when we don't know which data type that we are going to work with when we're calling this function. Therefore, the function will choose automatically the data type for us itself.